let's talk about the 3 ways to prove triangles are similar. Remember, similar figures are the same shape, just a different size. In similar figures, any similar figure, the angles are congruent and the sides are in proportion. So we have 3 postulates that we have learned about proving a triangle similar. The first one is the AA postulate, or angle similarity postulate. The second one is the side angle sides similarity postulate, and the third one is side similarity postulate. Remember, this little symbol right here means similar. It looks like the congruency symbol, but without the little equal sign underneath of it. Okay, so the first one is angle. And the postulate says that if 2 angles of one triangle are congruent to two angles of another triangle, then the 2 triangles are similar. Okay, so if I look at my diagram over here, I have an angle here of 57, and I have an angle over here that's also 57. So that's one pair of congruent angles. And then I have another angle here of 78, and I have another one here of 78. So I have 2 pairs of corresponding angles that are congruent, which means that my 2 triangles have to be similar. This is a similarity statement right here. So if you're ever asked to write a similarity statement between the 2 triangles, that's what it looks like. Just make a note that you might have to find your third angle. So just keep a note of that you might need to find the third angle. Okay, and we remember how to do that. The sum of the interior angles of any triangle always add up to 180. So if I needed to find B, I would just take 180 and subtract the 57 and the 78 from it, and that would give me B. It would also give me E because I would be subtracting the same 2 numbers. So that's why you really don't have to find the third angle. If you find 2, then the third one is automatically congruent. Okay, so the second postulate we learned was the side angle side postulate. And it says if one angle of one triangle is congruent to one angle of another triangle, and the adjacent sides, remember adjacent means right next to, are proportional, then the triangles are similar. Okay, so if I look at my diagram over here, I have one pair of congruent angles, and I want to know if the sides that are adjacent to that angle on both sides are in proportion. So the way I like to do this is put my finger on the 57 and say, the side that is on the right, I'm going to color code it. So I'm going to highlight it in pink, and then I'm going to put my finger up here, and I'm going to say the side that is on the right of the 57 would be this side right here, which would be the 12. And then if I put my finger on the 57 down here again, and I highlight the side that's on the left of the angle, that would be the 15. And if I do the same thing up here and highlight the side that's on the left, that would be the 18. That just helps you set up your proportions correctly. So I'm going to set up pink over pink equals blue over blue, and I want to see if those actually do equal each other. So pink would be 10 over 12, and I want to know, does that equal my blue? So I'm going to do the blue of the left triangle because I did the pink of the left triangle in the numerator on the left side of my proportion. So 15 over the 18. Okay, so this pink over that pink equals this pink over, or that blue over that blue. So when I cross multiply, I'm going to get 10 times 18, and I want to know, does that equal my 12 times 15? Well, 10 times 18 equals 180, and 12 times 15 also equals 180. That means those 2 sides are in proportion. So since I have my two adjacent sides and this angle that's included between them is congruent, then that falls into my side angle side. Remember, this is not the same side angle side postulate from our congruent triangle unit. This is a side angle side similarity. Our sides are not congruent, they're just in proportion. All right, the last postulate that we have that we can use to prove triangles are similar is my side, side, side. So my side, side, side similarity postulate says that if all three sides of one triangle, so all three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. So I like to color code these as well. So if I look over here at my two triangles, the way I like to do this is pick out my shortest side of each triangle. So that would be 10 and 12. Okay, so I'm going to highlight those two to go together. And then the next two sides would be 12 over here, because that would be my middle length, and 14.4 would be my middle length on that triangle. And then I would color code the longest two sides. So that would be my 15 and my 18. And again, that just helps me set up my proportion correctly. So I'm going to start with pink over pink, so 10, and I'm always going to go from left to right. So left in the numerator, right in the denominator. So pink over pink, I want to know, does that equal, let's see, let's do green over green. So that would be 12, because that's for my left, over 14.4, because that's for my right. And I want to know if that equals my blues. So that would be 15 from my left over my blue from my right, which is 18. Okay, so we don't have to cross multiply here. We can simply just put these in our calculator and see if they actually are congruent. So if I put in 10 divided by 12, I get 0.83 repeating. So now I have to see, do I get 0.83 when I put in 12 over 14.4, so 12 divided by 14.4. Oh, that does give me the exact same answer. And now I have to try 15 divided by 18, and that gives me the same answer as well. So these are in proportion, and we can use the side, side, side postulate, similarity postulate to prove that. Okay, so let's do some practice. Okay, so we are going to explain why the triangles are similar, one of our three postulates, and we're going to write a similarity statement. Okay, so I always look at what is it that they give me in my triangles or in my diagram, and that kind of helps me know which one of these three I'm going to try for first. Well, since it gives me two angles here and it gives me two angles here, I'm going to use that to try to figure this out. Okay, so it gives me that this is 92 and that's 92, but it gives me that that's 49 and that's 39. Well, before we just say, no, they're not similar, let's go ahead and figure out what is S. If I take 180 and I subtract 92 from it, and I subtract 49 from it, what do I get? Well, 180 minus 92 minus 49, that gives me 39. So S has to be 39 degrees. Well, if I look over here at this one, if I take 180 and I subtract 92 and I subtract 39, what do you think I'm going to get? Well, I'm going to get 49. So that would be this angle right here. So these are similar triangles, and they're similar because of angle, angle. We really didn't even have to find that one. Once we found this one, that gives us one pair of congruent angles, and that gives us a second pair of congruent angles. So we're going to say that these triangles are similar by A, but we have to make our similarity statement. So when you make your similarity statement, you have to draw the little triangle symbol. RQS. What corresponds to R? Well, R corresponds to U, and I know that because they have the same measure. Oops, that should be a U. And Q corresponds to T, and S corresponds to V. So that should be UTV. Okay, so let's look at the next one. The next one, they give us two sides, but I also notice that they give us some vertical angles. And anytime they give you vertical angles, you can always mark them congruent to each other. So since I have side measures for two of my sides and I have an included angle between them that's congruent, I'm going to check for side angle side. All right, so what I need to do is I need to say, all right, 18 is bigger than 16. So the 18 has to go to the 27. And the 16 is smaller than the 18, so it's got to go to the 24. So we have to see if 18 over 27 is congruent to the 24 and the 16. Actually, that would be 16 over 24. So 18 over the 27, I want to know, is that equal to 16 over 24? Again, I went left over right equals left over right. When I cross multiply, I get 18 times 24, and that is 432. And when I do 27 times 16, I get 432. So it is good. So this would be side, angle, side, similarity. And our statement would be triangle HGJ is similar to triangle. Well, what goes with H? That would be K. No, what goes with H? That would be L. Got to be careful. G goes with K, and J goes with J. Okay? All right, so let's try one more. Okay, so this one down here, we have three sides. So it gives me my side measurements for all three of them. So that tells me that I'm probably going to try to use this one right here. So I need to set up a proportion for all three of them. Well, these are isosceles triangles because they have two congruent sides, right? So I really only have to do two because two of them will be the same. So 12 has to go to 15, and 8 has to go to 10. And I want to know, do those equal each other? Well, let's see. 8 over 10, if I cross multiply 12 times 10, that's 120. And if I cross multiply here, 8 times 15, well, that also equals 120. So it checks good. All right, so let's look at the next one. The next one, oh, we forgot to do our similarity statement. Okay, so we know that all three sides are similar. So side, side, side is going to be our postulate that we're going to use. Then we need to do our similarity statement. So triangle ABC is congruent to triangle. What goes with A? That would be M. What goes with B? Well, that would be N. And what would go with C? That would be P. And really, because these are isosceles triangles, it doesn't matter if you swap those around. Usually it matters, but in this case, this is a special case. It doesn't really matter. It's the same triangle either way. Okay, number 4. Number 4, we need to figure out are our sides or our angles? Okay, so this is a little triangle that is nestled inside of a big triangle. So look at the little triangle and look at the big triangle. And if you notice, both of these triangles share vertex A. So when they two shapes share the same side or the same angle, we call that a reflexive. So we can say that it's congruent to itself by the reflexive property. Okay, so they share a congruent angle, or an angle that's congruent to itself. So what we have to do is see if these sides are proportional to these sides. So see this 3.5? That's just extra information that we really can't use. So we're just going to leave it there. All right, so our big triangle on this side, our big triangle has a side of 3 plus 3, or 6. And I'm going to put that under the same side of the little triangle, which would be 3. And then look at this side. The little triangle has a side of 2, and the big triangle has a side of 2 plus 2, or 4. Well, I know that those are equal to each other because 3/6 is 1/2, and 2/4 is also 1/2. So those are definitely in proportion. And since I have my reflexive angle, I can say side, angle, side, similarity. If I wanted to write my similarity statement, I would say triangle ABC, or ADE, that's the little one, is similar to triangle ABC.